Hello everyone, I'm a security software engineer from Alibaba Cloud Container Service team. My name is Kwangda Hu. Today I'm glad to share the security solution on ACK. This is the agenda of the slides. The first part is about why container need security more. And in the second part, we will introduce what is the security architecture design on ACK. And then we will show the key security feature illustration. And in the end, let me show some demo. Okay, why we need container security? Based on the State of Container and Kubernetes Security Report from StyleRock this year, in the past 3 years, there is more and more enterprise use container technology in their production environment. And we can see the security is the biggest concern in companies' container strategy. In the same time, the threat is everywhere. According to the statistics, there is more than 25 CVE vulnerabilities explored in the past 3 years. So based on the huge challenge and the customer requirements, in this part, let me introduce our solution architecture design. Based on the huge challenge, we propose our high-level security architecture. In the basic infrastructure security layer, we have the solid security feature provided from our private and public cloud platform. Based on that, we implement RAM integration authentication and the RBAC authorization and the auditing for Kubernetes API server and ICE resource. And also, we provide an open source solution called kube2ram for the fine-grained RAM role in workload pod. In software supply chain layer, we support image signing, scanning, and secure distribution during workload building and deploying. In the runtime security layer, we have sandbox container, which provide an independent kernel to enable enhancement security isolation, and then also we support runtime monitoring and defense. This page is the component diagram of our security framework. We have access control, network security, and SSL certificate service in our infrastructure platform, and we integrated RAM and a third-party SSO solution for authentication. And there is a whole fine-grained RBAC authorization access control framework. Besides, we have security hardening on ACK nodes, and there are security management solution for data encryption at rest. In runtime layer, we have security center for container runtime monitoring and the PSP support for pod security context admission control. Okay, this part is a feature illustration. Let me show some more details on our security features. The first feature is fine-grained access control. We support both access control on cloud resource in management layer and the Kubernetes cluster resource access control in data layer. The administration could easily authorize one RAM sub-account on console with our preset RAM class role template, and also we support customized class role and banding. Before the configuration finish, we will check the RAM authorization for cloud resource and auto-generate the RAM policy if management access control is not finished. For default configuration security, in the first step, we have hardened cluster control plane security based on CIS Kubernetes benchmark. And in second step, we will ensure system pod and controllers are configured using the best practice. And in the second step, we will also ensure there is no critical CVE vulnerabilities in system pod images. All of these security hardening validation were integrated into our daily scanning job. For auditing, we support different kinds of auditing, like API server auditing, ingress traffic auditing, and Kubernetes resource event auditing. The agent from SOS service will help us to collecting the log, show them in console, and provide the powerful searching abilities. In audit log, it can help the administrator to track operations performed by different users, which is an essential part of security maintenance operations. And in ingress traffic auditing, we can find the inbound and outbound traffic and the statistics of PV and UV. In Event Center, we can find the key event for cluster DevOps, like the events of image pull failed and pod eviction and so on. We provide a cloud-native supply chain to deploy only trusted container in cloud. With the cloud-native supply chain, you can configure the validation policy to automatically block risky image to deploy. Besides, you can require image to be signed based on your own key during the deployment process, and then you can also enforce signature validation when deploying. Okay, for the DevSecOps scenario, in our container registry service, you can freely combine tasks such as image building, image security scanning, image synchronization, and image distribution in a single delivery chain. The cloud-native supply chain is fully observable and traceable. Compare with the Docker containers. Sandbox containers enable your applications to run on a lightweight virtual machine, which provides an independent kernel to enable enhanced security isolation. Sandbox containers are suitable for scenarios such as load isolation among multi-tenant and isolation of untrusted applications. In addition to enhanced security, sandbox containers have little impact on performance and it can offer the same user experience as Docker containers, such as the feature of logging and monitoring and elasticity. In container runtime, the runtime monitoring and defense is an important security feature. In Alibaba Cloud Security Center, it supports container risk detection and alerting, including the feature of malicious image startup detection, intrusion into containers, the container escape, high-risk operation alerting, and so on. In the picture, we show the alerting and isolation for Grabboard, which is the first ever minor cryptojacking worm found in image on Docker Hub. Security management is essential to enterprise container application on cloud. For the security management solution, we have ACK KMS plugin, which based on the Kubernetes encryption provider framework. User could encode security data at rest with customized key in KMS service. Besides, we provide ACK Security Management Manager, which help you to import, using, and synchronize the secret that are managed by an external security management service. User can directly install it in our app catalog, and both of these two solutions is open source. You can find the code in GitHub. At the end, let me show some demo. Okay, let's begin the demo. I have logged into our container service console with my primary account. The first demo is about the RBAC authorizations. In authorizations page, you can see we support both RAM user and RAM roles. In RAM roles tab, you can input the role name here, and our backend will automatically validate the input role's name. Back to the RAM user tab, you can choose all of the users or just one. I will choose a user and click Modify Permissions. This is the RBAC access control page. You can see there's already an existing permission bounding here, and we support 4 kind of preset permissions. For the administrator permissions, it means the authorized user will has all permissions for all kinds of Kubernetes resource. And we also support customized permissions. You can create your own cluster role in target cluster, and it will show this in this pop menu. And you can select the target class role to bound on your sub account. Okay, I will add a new bounding. First, select a target cluster. Then select a namespace and select developer as the permission. Okay, the notice here means the selected user has not finished the RAM authorization on the target cluster. So we have to finish these 3 steps on page. First, I will copy this text and go to the RAM console. In the policy page, click the create policy and then input the name. Here we should select the script mode and paste the text here. Okay, I have created a new policy. Go to the user page and search the target sub-account. Add permissions. In customer policies, search the policy I have created. Okay, we have finished the RAM configurations. Then go back to the container service page and click the submit. Now you can see we have finished the authorization. Okay, let me verify the authorization. I have switched to a new browser with the authorized sub-account. When I refresh the page, you can see the new authorized cluster show here. And I will test the permissions. Yes, we have not configured the node list permission, and it should not have the permissions to list the namespace. In the deployment page, it can only see the authorized default namespace. Okay, let's come into the second demo. It's about the binary authorization solution. Firstly, we should create a signing keys in the KMS console. Firstly, we should choose the right region and create the key. Here, choose the RSA for the key spec and choose sign verify for the purpose and input the alias name. Here we have created some keys for this demo. Then we go to the container signature page in the Security Center console. Firstly, we should create a witness. Input the name and select the keys we just created. In the Security Policy tab, we should create a policy. select the target cluster and the namespace in which the image would verified by this witness, and then input a description. Okay, the policy is created successfully and we should enable it. Then we go to the container registry page. Firstly, we need to create an enterprise instance. Please note the specific here should choose advanced. Here we use here I already create an instance today, and we will reuse it in the instance page. I have created the repository namespace. You can find the image signature here. Create a signature rule. Choose the RSA PSS shard and select the witness. Then select the scope. All images in this namespace would be automatically signed in by this rule. In the repository page, if the picture here is green color, it means the signature is enabled. Okay, let's back into our container service console. Select the target cluster and we try to log in to it. Okay. Firstly, we can find the Creatis validation webhook has installed successfully, and then we try to deploy a deployment without signed image. As you can see, the deployment is denied because the image is not tested. Then we create a new deployment with the signing image. And you can see the deployment is created successfully. And we can find the pod is running. Okay, the last demo is about container runtime detection and alert. In this video, first we create a Struts web service, and then we run a malicious command with remote code excuse vulnerabilities. Here is the remote commander. Then we back into the Cloud Security Center console. We can find the alerting on the host side and the network side. We can find the attack IP and URL and the post date. You can find the command line here. And then we switch to the handled page. Okay, we can find the malicious remote request is intercepted by our security center. Okay, that's all demo today. Thank you for watching.